It is a cold, nasty day. We've got to go perform a quote. We're gonna hop in Mellow Yellow. Yes, man behind the scenes, that's just for you. We're gonna hop in Mellow Yellow and go get this quote performed. Well, we made it. And I'm here to tell you, I think it's getting colder instead of warmer. Normally when the sun comes up, it gets warmer, but it is definitely not doing that today. We're here at the site for a potential pond build. This landowner has built a really nice shelter house so they can get their camper in. They've got a storage building. They have all their utilities over in this corner. And the long-term goal is to build a house kind of right in this area. And then we do have some set points over there by that swing set. Somewhere in that corner, there is going to be a long-term septic system field bed with a tank somewhere over here by the house. But they want this field to have a body of water in it in some way, shape, or form. And as we go up here to this top side, the land actually lays quite well for a pond. It's got a natural drainage coming in, I guess you could call it from the road ditch right here in front of us. So if we get up here, you can kind of see where the funnel kind of starts to develop itself. And we will go to the software so you guys can see this as an aerial view. But you have a funnel on the left-hand side. You have a nice big hump in the middle, and then another funnel over here on the right-hand side. So all of this area that has rainwater catches, and it all runs downhill. There's actually a tile that runs down this ditch, which if a pond is built here, if they like our price, we'll have to evacuate that tile so that the water can retain here, as we darn sure don't want it to go under the dam. But you can see here we've got nice elevational change, high spot, low sag, and then another high spot. And that bottom, yes, the elevation runs down in that direction, but that bottom follows that same contour in both areas. And this property owner has two potentials. They are on a budget. They don't want to go over that budget, but I have told him his long-term goal is to sit on his front porch and look out over a nice body of water. He does want it to be fishable. He does want it to have the proper depth and habitat for fish to survive. And here in Indiana, everybody says 7 feet. We like to say 10 feet. Not that you have to have 10 feet, but in order for your fish to survive when it gets as cold as it does here sometimes, we like to say you need 10 foot of water. So he's got two options that he is wanting me to provide him numbers on. The first option is basically taking from that grass right there that you guys see, that tan colored grass, and making a 60-yard levee that would basically come over to this grass here. That 60 yards of levee will get him a decent body of water. It'll probably bring it somewhere right around in here. So I'm guessing he'll have 1/8 to 1/4 of an acre. But as we walk this property, and knowing the house is going to be over there from the Jeep to that building, somewhere in that area, I told him, I think you're going to be able to get more bang for your buck because we're not going really deep. It's all downhill pushing. It is going to require a core. We won't build a pond without a core. But if we come over here to this corner and I get on this high side, you'll actually, hopefully you can notice here on camera, you're going to notice that this patch of grass right here is really close to the same elevation. If you go to the camper, you've got 2 tires on the bottom of the camper. The front tire is behind a post that holds the roof up on that structure. You go downhill just a little bit and there's a sprig of grass over there, right about right there, I think, where my finger's at. But this elevation and that elevation are really, really close. So you can double, if not a little bit more than double, the length of levee, but you're not talking about a lot of height because of the way this lays in here. Having the two high spots on each outside corner, I believe he can get twice the size of pond for not twice the price. So he's going to have the depth down here on this bottom end because of the natural lay of the land. He's going to have his 10 foot on this bottom end, and he's got all that dirt in the center that can be hogged out, pushed downhill into the core. The core is going to probably end up right down here on the front side of his food plots, be on the front third of that levee, and then the inside slope would be a little bit steeper, but the back slope could be nice and long and drawn out on the back side. And I still truly believe, instead of connecting this to that hump in the middle, which is that 60 yards, you just take that levee and you run it downhill a little bit, and you run it all the way over there to that long sprig. And I truly believe it's not going to be double the price. Obviously, I have to go run those numbers, but it gives him the long-term goals. And I made sure that they were aware, if you do the 60 yarder, you build your house and you're like, dang, my pond's 100 yards from my house. Yeah, I've got the view, but it's not a big surface area of water, that big mirror, right? I feel like he's going to want to redo his pond. Well, in order to redo the pond, because of how the land lays and where you're going to have to take that dirt from to put this levee in, you would actually have to tear it out. And then the question comes, is it usable at that point in time? Because it's been a pond for years, if you will. If you can afford that next step to get truly what you want without spending double the money, but to get double the surface area of water, that's where they've got to weigh those options. Does it fall within their budget to get the full amount of water that they want, or how much is it above their budget? And you know, it's hard for the contractor to know what that budget is. So I've got to run these numbers as though there is no budget, right? I've got to run these numbers so that we make money, but also we can satisfy the customer. Will he be happy with a 60-yard levee and a body of water over to that high spot and probably up in there somewhere? I'm not saying he won't be happy, but I think he's going to sit on his front porch one of these years and he's going to go, dang, I really wish I would have taken that levee all the way over. We also have to be mindful of the field bed that's going to go over there by that swing set. We have to stay 50 feet away from that and 2 foot in elevation lower with our water level to the bottom of their pipes. There is a hump in between that swing set and where our levee would actually tie in. So I'm not worried about any of that creeping over into the pond. It's actually going to run downhill and to the right. That absorption will go down, and then anything that it absorbs is going to end up being on the right instead of coming towards us. But if we step this off here, again, this is the sprig of grass I think we're going to tie into. And one thing that everybody has to keep in mind, we can take this levee straight across, but we're going to lose a lot of surface area of water. So I feel like we're going to be better, and so does the homeowner, if they can afford the full length, to come off of that sprig of grass, run it tighter to this point of woods right here where that sycamore tree is, the one with the white top, is actually further out in the field than that corner over there. So the back slope is going to be wider on that end, and that's going to skinny up some because we lose real estate in depth right here on this far end of the levee. And then we can actually roll that corner around and tie that core into this hillside so that we have a nice pocket We've got good usable dirt on this corner. You guys can kind of see where that runs into that valley. We can take this dirt downhill. We can take that hump downhill, and then we just keep carving this out until we get the amount of dirt that's needed to get the elevation to inshore 2 foot of freeboard. That means from top of levee to actual discharge pipe is 2 foot of difference. And then that levee would run straight across, tie in the inside slope, tie in the long back slope, because he does want to mow it, maintain it, and manage it. So if there are any small seeps or anything because of crawfish, etc., he sees it before it turns into a big problem. So realistically, this land lays exceptionally well for a pond build because of the extra dirt in the center, the 2 valleys. Honestly, it'd work out great to clog up both of those as long as they can afford it. But let's step this off and see. My guess is we're going to be 150 yards from here to there. And what I have to keep in mind is it might be a little shorter than 150 yards straight, but we've got to curl this corner in, so that's going to add some length to this levee. But let's step it off. So that there, from this sprig of grass to all the way over there where we were standing before, is 115 yards. And again, now that we can see it from this side, from this grass, we would run it straight through. You can see where it skinnies up. And then we would turn, I don't want to call it a 45, but I guess for conversation piece, we'd go out straight, kick a 45-degree angle, and run it up to that high side. You can see the mailbox post with the black mailbox on it. Just downhill a little bit from there is where that levee would tie in to get that elevation, the same as this elevation. Have that core go into the higher ground, take this core, tie it in right over in here, and the water level would probably end up, that'd be about 2 foot of freeboard right there. So that water level would run right through here, all the way up into there. Then it would turn where that funnel starts, and it'd run almost parallel with the highway up there, and then kick back over just about where that telephone pole is and start running down to where the levee would turn up there. So this honestly could be a really, really nice body of water. A lot of surface area. We're probably not going to be able to get a lot of depth up there in that top side, because that's going to be the head section. A lot of this is going to be rainwater, but it is going to catch some up here in this corner and run it down. So we'll want a nice long slope up there so it doesn't wash as bad. And that head section still, I think we can achieve probably at least 4 foot of water. And then by the time we carve all of this out and use it for that dam, definitely down there in that lowest spot is going to end up being probably close to 10 foot deep, somewhere in that 8 to 10 foot deep at the deepest point, and then shallow up as we get up through there. But the bulk of this pond is probably going to end up in that 6 to 7 foot deep range, and that is a very good depth for a pond in this area. And as I stated earlier, we are going to go back to the computer, show you guys all this as an aerial view, dirt direction, the way we got to push, and how that levee is going to tie into this. So here shortly we'll be back at the computer and finish up this design. Well, here we are back at the drawing board again to finish up this pond quote, as you guys saw from the boots on the ground. We've got a pond that's going to go somewhat in a draw. If you look here on the image, you can see this green path right here. That is, I don't want to say the center point of the levee, but that is going to be crossed over by the levee. And the reason this green patch is here, they actually installed a field tile that runs down through here to drain the top side of that field. and mitigate the amount of wash that came down through here and it runs into the woods. Over here on this end, you can see the U shape. That also was field tile. That was installed years ago. So assuming this customer likes our quote and decides to have us build this pond, we will dig through this field tile here, cut it off completely, probably rip it out of the ground as far back as we can to get it away from the potential levee. But that's only if we get the job. So let's kind of start discussing some set points we have here. The property line is right here along this tree line. We're going to mark it out in red. It does extend further than this to the left, but I need to mark it out in red here so that we can, well, shoot, I did it again, so that I can help you guys understand what all is going to happen on this side of the property. Again, we're going to mark it red. We're going to call that, well, maybe, don't have my keyboard working. Property line, and you guys can see this pops up a great big keyboard for some reason. That's what it's doing to me today, and I'm figuring it out. I don't have it plugged in. So, done. Property line, save. Now that keyboard won't pop up anymore. We've got a couple of other set points. There is going to be, long-term, a home built on this property. The current dwelling that you guys saw is not on this map. It is roughly right here. And when I say dwelling, it's a pole barn. It's a storage area for their camper. They use this as a campsite today. So we're going to mark that one as pole barn. And they have also had this ground perk tested, if you will. I call it a soil test. A lot of people from just, I don't want to say years ago, but the term perk test has been utilized for years. So that's what people call it in some cases. So we're going to give you guys that term on this video here as well. But there has been a soil test performed. It is somewhere in this area here. The property owner is going to get me that map so that I can ensure I understand that location. The reason that location matters is long-term goals. This property owner would like to have, you guys saw us step it off earlier, he would like to have a levee that is at least 100 yards long to get the surface area of water that he believes will be appealing to his eye just in front of his home. So you guys saw I walked from roughly right here, might be actually a little bit further, right here, and then I walked 100 yards this way, and I'm going to guess that currently because I am drawing a shape. You know what? Nope, we're going to back up. We're going to do that differently. So that I have the dimension, I can draw the shape over top of the line. We have to ensure that our water level is 50 feet away and 2 feet in elevation lower than the actual field bed that will be installed in that soil tested area. So as you can see there, right there, oh, I messed it up. That's close enough. Right there is the 300-foot mark. That we're going to draw in purple. We're going to call that the dam. So you guys can see how that dam kind of stretches out there. And again, that field bed potential down here on this bottom, the way these field beds work out, you have to run the septic system on contour. So if this corner checks at a foot of elevation, this corner here must also check at a foot of elevation. Now you can have an incline from there to here of 3 feet, if you will, depending on the size of your field bed. But if this is 3 feet, this over here must also measure 3 feet. So that rectangle for that field bed may not be laid in there perfectly. It may set at a little bit of an angle, for example, from this corner to this corner, if you will. So there's a set point, but we don't know exactly where that set point's going to be. So if that set point is high enough that it allows us to have 50 feet of separation from this corner of the field bed, or if the field bed's capable of going back here towards the woods, honestly, that's better for the field bed because the roots actually help absorb some of that effluent that goes into the actual field bed. We just have to make sure that we have 50 feet from the corner of the field bed to the actual water, and then that water's elevation must be 2 feet below the bottom of the field bed. I'm explaining all of that because it is very, very, very important for people who are going to build ponds at, around, or near septic systems. This is the state of Indiana that I'm talking about. It may be totally different in another state, but you should always check your regulations, because it would be really, really bad to build a pond to then have to move the septic system, and or to build a pond with 2 foot of freeboard, meaning you've got 2 foot of elevation from your water surface to the top of your dam, to then have to lower that water level to get the proper distance away, or the proper distance of elevational change between the bottom of the field bed and the actual pond. And I am here to tell you, the health departments, I'm sure in every state, have the ability to make you do that if you don't check your regulations and your code first. So with all that being said, we have a purple line over here that represents the levee. We spoke about that a little bit earlier. Now I'm going to draw the actual shape of the pond. I'm going to try to get in here and get pretty close. That water line will actually run parallel with a driveway, which is currently parallel with the red line. It is not on this map, but as of today, there is a driveway there. And we're going to try to run this as far up into this corner as we can, and then run it over. And then there's going to be a slight angle with the way this ground lays that'll run almost over into here. And as you guys remember from the video, I did state that the levee is going to have to turn at, for conversation piece in the video, I said 45 degrees. So now that's that degree of angle right here. I'll explain that here in just a minute after I get done drawing this shape. Now we'll connect back over to this corner, and be mindful. This shows an acre. It may or may not be a full acre when we get done with it. The reason for that is that acre is being pulled off of a straight line here. There are some humps and some small valleys out through here that might make that water line not be perfectly straight, and it'll kind of curve back in and out. And again, we can take the dozer and contour all of that, but this is the head section of the pond. So what we have to be careful with up in this area is getting too steep of an entrance into the pond, as the only thing that will ensure is that dirt washes down here to the bottom towards the levee. Now, I said that I would explain the 45-degree angle. In order to run this dam perfectly straight, we would actually have to come all the way over into here, whereas there is a high spine right through here that runs from the road down to basically right around in here, and then that bottom end of the field's kind of flat. So what we're going to have to do in this area off the end is take our core and run it at an angle into this high side to ensure that we're not making too large of a pond. But realistically, what that comes down to is going above and beyond the customer's budget. There is a budget for this pond build. They want a pond, but we're going to quote 2 options. The dream of the customer is to have this 100-yard levee plus the 45-degree angle, which is where it ends up being around 110 yards to 120 yards. That's close enough for what he's wanting, curb/eye appeal. But we're also going to quote the potential of bringing it down to a 60-yard levee, which means we would move up the hill to get closer to the opening of the funnel, if you will, that runs down this direction. so that we can hold a body of water that's going to be smaller, but also secure it by having a smaller levee, but yet similar water retention. My concern with that only being 60 yards, if you start to calculate where 60 yards gets you, I did step that off camera. The concern that I have is, does it then even make sense to have that small of a body of water? I don't have the exact set points here to map it out, but I did step it off this direction and this direction, and my guess is he's going to go from what could potentially be a 1 acre pond down to what most likely will be roughly 1/4 to 3/8 of an acre. And it starts to beg the question, since the customer's dream is to have a larger body of water, if you will, directly in front of his house, does it make sense to go with a small body of water in which he may not be happy with, which in turn means if he's not happy with it, he's going to spend that initial money? Well, to build the pond he really wants, which the equipment's already on site, we're doing a little bit more dirt work. Our core is going to be basically twice as long, but it's not twice the amount of dirt that's moved because of how this land lays out. Some might think, well, you're going from 60 yards to 120 yards. That's going to be twice the cost. Well, I can, from a commonsensical thought process, that makes sense. But realistically, when you're clogging up these land funnels, if you will, I know I keep calling them a funnel, but we're not just digging a hole here. What we will do is dig the core, come up in here, find the good dirt for the core after we strip the topsoil 3 directions, uphill, sideways, and across. We'll find that good dirt. We'll push it downhill, so gravity's in our favor, to fill in the core. We'll run the roller in that core, and once we get back up to original grade, that's when we'll start putting the pitch, the inside slope, and the outside slope on this levee. But we're not necessarily moving twice the amount of dirt simply because the levee is twice as long. The biggest and easiest explanation is from this point over, the hillside is taller. Well, we're going to move that levee uphill to inshore a shorter levee. Yes, we're moving less dirt, but we're still not moving twice the amount of dirt. So that's the easiest way for me to explain it. And then, as you guys always remember, I'll draw this out on the side here. Down towards these woods on this side of the purple line, what you're going to end up having is virtually a rectangle and 2 triangles. And this is if you cut a levee, a dam in half, and you were to look at a properly built levee, what you're going to have is a back slope. The next portion of a levee is the core. Typically, that core will be slightly lower than the bottom inside corner of your actual back slope. It will then run to the top, and this is where you get your flat surface on top. Depending on the type of dirt and depending on the type of soil underneath the surface, the subsoil, we might need to be a D4 blade, so let's just call it 8 feet wide, or we might end up needing, where you have seen some of our pond builds, being an 850 blade, which is 12 foot wide. And that comes down to how hard it is to seal. But this is going to be your core. Let's save that. We're going to save that as red because that's very important. It stops water, and red means stop, right? So that's going to be your core. And then, last but not least, you're going to have an inside slope. And that typically is similar to the outside back slope, but it can be steeper. I'll explain that here in just a second. I don't remember what color I used. Inside slope. Now, just a moment ago I stated your inside slope might be less or more steep than your back slope. We always recommend on these back slopes you put a soft enough slope that you can maintain this entire slope. So all the way down through here, we would want that back slope to be slow enough. A 1-to-1 is steep. A 4-to-1, you're starting to get to where you can safely and comfortably take a riding mower across it and or a tractor. The reason we recommend people to maintain their back slopes is it is impossible to guarantee a pond will never leak. You have crawfish potential issues, you have tree root potential issues, you have muskrat potential issues. There are a lot of outliers to our work that we do not have control of. So if you always mow this back slope, which again is this area all through here, you will know if you have a wet spot way before it becomes a very large problem, meaning you have to demo the entire levee to fix the problem. Whereas, let's assume you have crawfish. They've bored their holes in, they've bored their holes into your water, and now you have a small leak. Number one, you can hire people to eradicate the crawfish, and now you have a small issue that needs to be repaired opposed to a complete demolition of the dam to repair the water leak. So hopefully, oh, I did forget one thing. Their hope is to build a new house right here, and they are hopeful that this is capable of being a walkout basement with a patio. And when they walk out on their patio, they have a waterfront view. That house is not there today, but that is their ultimate hope. So with all that being said, this allows me to get all the dimensions set, the potential area that we're going to be working in, and better assumptions on the amount of dirt that we're going to move so I can provide this customer a closer estimate. Since we are going to quote this two ways, that being the 60-yard levee and the 100-yard levee, I will actually give this customer a range. They're not for sure which one they're going to choose, but they will know the lower end of the spectrum versus the higher end of the spectrum. And the biggest difference is you're getting a 60-yard levee versus a 100 to 120-yard levee. This is your price range for both. You're going to end up either at the lower end, in the middle, or at the higher end, but at least they know they can budget for the top number. They can get their quotes on their home. They can get their quotes on their septic system, and they'll be able to have an all-in number in which they're going to have to cover at the end of this project. Hopefully you guys like the video and the layout and the explanation of how we do our inside slopes, our cores, and our back slopes. And as always, like, comment, subscribe.